Look at this sequence. 5 by 2, 13 by 6, 11 by 6, and so on. Do you think this is an AP? Let's leave that task for some other time. For the time being, believe me, it is actually an arithmetic progression. Although a slightly difficult looking one. My question is different. Can we find the sum of first 17 terms of this AP? You know, if you physically try to do that, it's going to take you ages. You can still do it. But there is a better method. In fact, there is a formula for calculating the sum of n terms of an AP. And believe me, it's an easy formula. So here is the formula. Sn equals n by 2 into 2a plus n minus 1 into d, or n by 2 into a plus l, where l is the last term and a is the first term. Now let me go ahead and prove this formula. Before that, I think it's important for you to understand the equivalence of these formulas. Look at the first main formula. 2a plus n minus 1 into d. Can I write it as a plus n minus 1 into d? Now compare it with the other formula. A is as it is. A plus n minus 1 into d. That is the last term, if the total number of terms is n. So we have an L there. So the two formulas are actually the same. Let's get back to proving this formula. So we take an AP, a general AP, which means the terms would be as boring as A1, A2, A3, A4, and so on. Now, A1, we write as A, that is the first term. A2, remember, A plus D. A3, A plus 2D, and so on. And AN is A plus n minus 1 into D. Once you've written this, what we have to find is the sum of all these terms. That is the left column, if you see. A1 plus A2 plus A3 till AN. So, let's denote this by Sn. Now, this should be equal to the sum of the right hand sides. That is A plus D plus A plus 2D and so on till A plus n minus 1 into D. Let's call this equation 1. Now I'll do a small trick and listen to me very carefully. The right hand side I will write in reverse. Fine. So I'll write the nth term first. That is A plus n minus 1 into D. Then the next term A plus n minus 2 into D and so on. So the last would be A. Let me call this equation 2. Now something interesting will happen. Let's add the left hand side. What do we get? Sn plus Sn, that is 2Sn. Now this should be equal to, and now is something that we have to do carefully. Add the corresponding terms. So A plus n minus 1 into D. What does that give you? Yes, 2A plus n minus 1 into D. So far so good. Now we add the second corresponding terms. So A plus D plus A plus n minus 2 into D. And what do you get? Think, do, and see. 2A plus n minus 1 into D again. Third, once again it will be the same. So on. So we get 2A plus n minus 1 into D n times. So what is the sum? N into 2A plus n minus 1 into D. Now it's looking beautiful. So Sn equals, bring that 2 down here, n by 2 into 2A plus n minus 1 into D. And before you realize, you have proved the formula. So the sum of n terms of an AP, as I said earlier, is this. Now I'll go over the equivalence again. L was the last term, the nth term, A plus n minus 1 into D. So Sn equals n by 2 into A plus n minus 1 into D. I split 2A. Look at it carefully. It is n by 2 into A plus. Yes, A plus n minus 1 into D is L, the last term. Now, once we've proved both the formulas, I think we need to get back to our example. And what do we have in the example? 5 by 2, 13 by 6, 11 by 6, and so on. First term A is 5 by 2. D is the common difference. And finding the common difference is really easy. 13 by 6 minus 5 by 2. That is second term minus the first term. So 13 minus 15 by 6 or minus 1 by 3. So we know A, we know D, and what is N? Remember, we wanted to find the sum of first 17 terms. So N is 17. Now all you need to do is admire our beautiful formula and substitute. There you go. Now what are you waiting for? Simplify. So we get 17 by 2 into 5 plus 16 into minus 1 by 3. Solve it further and you get minus 17 by 6. So the sum of 17 terms is minus 17 by 6.